First of all, whatever data you have provided, that data first we write that data. Here, simply supported beam is given. Simply supported beam is given. A and B, which is subjected to point load 20 kilometer, 8 kilometer into meter, 3 meter, 2 meter. Then here first we calculate reactive force according to equilibrium condition. Here simply supported beam is given, which is provided point load at the middle of the beam. Then to draw SMT and TMT, the couple is given. Here 8 kilometer meter moment is given. That moment is anti-clockwise. Here, first we calculate reactive force at A and B. Take first to find out RA and RB. Here, summation F1 that is equal to 0. Sign convention, upward force is taken as positive and downward force is taken as negative. The first reaction that is vertical upward, then downward minus 20 plus that is equal to 0. RA plus RB that is equal to 20, considering as equation number 1. Then second condition of equilibrium, summation A that is equal to what is the meaning of that summation A that is equal to 0? Algebraic sum of moment of all forces which are acting at fixed point must be equal to 0. We take algebraic sum of moment of all forces. Moment of force which is equal to the product of force and perpendicular distance. That product of force and perpendicular distance which is said to be moment of force. Here, clockwise moment is taken as positive, anti-clockwise is taken as negative. That is sign convention for moment of forces. Then here first moment that is anti-clockwise minus RB into distance, total distance is 5 meter up to the point A. Then second here this is also considered moment that is in anti-clockwise minus 20. Then this will also take clockwise 20 into distance is 8 that is equal to 0. Minus 5 RB minus 20 that is equal to 0. Minus 5 RB plus 40 that is equal to 0. 5 RB that is equal to 40. RB that is equal to 40 divided by RB that is equal to 8 kilo Newton. Okay. This is the reactive force at A, at B. Then we put this value in the above equation. So here minus 8, sorry, minus 5 RJ, minus 8, 60, that is equal to 0. 5 RJ plus 52, that is equal to 0. 5 RB, that is equal to 52. RB, that is equal to, we will get final value 10.4 kilometer. Okay. This is value for the RB. Then substitute this value in our equation. RL plus 10.4, that is equal to 20. RA, that is equal to 20 minus 10.4. RA, that is equal to 20 minus 10.4, that is equal to 9.6 kilometer. Once we find out values of RA and RB, then we substitute this value in the given diagram. 9.6 kilometer, 10.4 kilometer. Okay. This is first we calculate reactive force at the fixed endpoint A and B. Once we find out the values of Ra and Rb, then calculate SF and Bm in the second step and third step. And according to values of SF and Bm, we can easily draw the SFB and Bm. Okay, this is the problem. That problem is simply supported beam, which is subjected to point load and couple. Then how to draw SFD and BMD? That is the type of the problem. In this type of problem, we calculate in the first step reactive force or reaction at fixed endpoint A and B, that is Ra and Rb. Once we find out reaction according to equilibrium condition, summation of y that is equal to 0 and summation Ma that is equal to 0, then in the second step we calculate shear force. Step number second, SF calculation. This is simple way to calculate. First, side dimension, left side, right side, positive SF, negative SF, and calculation for shear force always start from right side to the left side. Shear force at the point B, right side, that is equal to 0, because first of all each point load is considered as a section. Left side, right side, left side, right side, left side, right side. Okay. Then the calculation for shear force always start from right hand side to the left hand side of the beam. Then here shear force at the point B on right hand side of that is equal to 0, because on the right hand side of the beam there will be no force. Okay, and that's why shear force at the point B on right hand side of the beam will be equal to 0. Okay, then shear force at the point B on the left hand side of the beam or point B, left side of the point B. 0, upward force, upward is negative. The value of RB, that force is given, 10 is already calculated, minus 10.4 kilo. Okay. Once we find out the values of shear force at the point P on left side, then shear force next point, this point is given, your C point, shear force at the point C, right side. In the portion CD, there will be no load in the portion CD, and that's why this value minus 10.4 kilonewton, this shear force will be continued at the right side of the point C. Okay, because in between portion CD, there will be no load. Okay, this value will be continued at the right side of the point C. Then shear force at the point C on the left hand side, downward is positive minus 10.4 plus 20. The value will get finally minus 10.4 plus 20, 9.6 kilonewton. Okay. Then here shear force at the point A, right side, this value will be continued at the right side of the point A, because in the portion AC there will be no load. Okay, any type of load, there will be no load in between the portion AC, and that's why this value will be continued at the right side. Shear force at the point A on left side, 9.6. Then upward is negative. The value of RA, this force is given 9.6. 9.6 minus 9.6, that will be equal to 0. Okay. This is the shear force. This calculation of shear force for all values. Means first we calculate shear force, that will be start from right hand side of the beam to the left hand side of the beam. Then each point load is considered as a section. It has two sides of that section, left side and right side. Here, shear force at the beam on the right hand side, there will be no load, and that's why that will be equal to 0. Shear force at the point P on the left hand side, 0 minus this upward force according to sign convention, upward force is negative, 10 minus 0 minus 10.5, 10.4, that is equal to minus 10.4. Then here, this value will be continued at the point C on right side of the beam, because in between the portion CD it has no load. Okay, minus 10.4 kilonewton shear force will be continued at right hand side of the point C. Then shear force at the point C on left hand side, minus 10.4 plus downward is positive plus 20, that will be equal to 9.6 kilonewton. Then again in the portion AC there will be no load, and that value will be continued at the right side of the point A, 9.6 kilonewton. Then here at the point A, upward force is given. The value already calculated in the first step according to equilibrium condition. RA, that is equal to 9.6 kilonewton. Then 9.6, that is upward force. 9.6 minus 9.6, that will be equal to 0. Then shear force at the end point will be equal to 0. Your calculation regarding shear force will be correct. Once we find out RA, RB, reactive force at fixed end point A and B, then in the second step we calculate shear force for all values. Then in the third step we calculate bending moment. Okay, bending moment at fixed end always equal to 0. Here, first we step 3, bending moment calculation. Again, applying two sign convention, hogging bending moment and sagging bending moment. Hogging means negative bending moment and sagging which means positive bending moment. That is hogging bending moment, negative bending moment. That is positive bending moment. Okay, that is the sign convention which is related to bending moment. Bending moment is the product of force into perpendicular distance. Then here first we take bending moment at D, that will be equal to 0, and bending moment at A again equal to 0. Then here, once we find out the values of bending moment at A and B, because both are fixed end of the beam, why it is 0? Since bending moment at fixed end point is always 0. Then bending moment at point C, remaining point. The first we take this value, that is anti-clockwise direction, that is sin 10.4 into distance up to the point C, that is 2. Then here again, this is anti-clockwise direction, that is again sin, sorry, if the couple is provided, then that couple is considered two section here. That will consider two section at the point C. Bending moment at the C on right side, okay. Then value will be 10.4 into 2. The value will get, I will just do the calculation. 10.2, sorry, 10.4 into 2, 20.8. 20.8 kilonewton into meter. Okay. If the couple is provided on the beam, and at that time, if you want to calculate bending moment at that point, here at the point C, couple is provided, and if you want to calculate bending moment at that point, then you will consider that point, bending moment at that point left side, and bending moment at that point right side. Bending moment at that point right side, you will get this value right side, okay, according to sign convention. Then here bending moment at the left side, how to calculate bending moment at the C on left side. Then already we put up this value 20.8. Then this will sagging bending moment, anti-clockwise is given. Then here sagging means 42, the value is already given 20. Then final value is 20.8 plus 20. Here, if you see here, the moment is anti-clockwise, then anti-clockwise is taken as negative for couple. Anti-clockwise is taken as negative. Anti-clockwise is taken as negative. That moment is taken as negative. This is anti-clockwise moment. That its value is 8 kilonewton. Then here you will get the value finally 20. Sorry, this is cycle bending moment. Cycle bending moment. The value will get 28.8 kilonewton into meter. I will just clear the concept. Here, bending moment at the point C on right side. If you see here, right side of the point C, we take anti-clockwise. Anti-clockwise means here that is sagging bending moment. The value of R means 10.4 into distance up to the point C on right side. 10.4 into 2, 20.8. Then bending moment at the point C on left side. Here 20.8 is already calculated. Then if you see this 8 kilonewton per meter, that is it will rotate anti-clockwise. Then anti-clockwise according to sign convention of bending moment, that is sagging, and clockwise according to sign convention of bending moment is negative bending moment or hugging bending moment. Here value will be positive. Why? Because the second bending moment 20.8 plus 8, 28.8 kilonewton per meter. Bending moment at the point C on right side, bending moment at the point C on left side. Okay. This is the DM calculation. In the first step, we calculate RA and RB. In the second step, we calculate shear force, and in the third step, we calculate bending moment. Then, according to that values of shear force and bending moment, we can draw SFD and BMD. Okay, how to draw SFD and BMD? I will explain. First, draw the baseline or a datum line. Here, first at the point A on left side, that value already calculated 0. Right side 9.6. Direction of the force is upward 9.6 kilonewton. Here, then here in the portion AC no load. Then no load means horizontal straight line. Draw the horizontal straight line. Then force 20 kilonewton is downward. Here force at the point C on left side again value 9.6 kilonewton. Then shear force at the point C on right side, that value is negative. Force is downward 10.4 kilonewton. Then in the portion CD again no load. Draw the horizontal straight line. Then force will go upward. This is negative. This is positive. This is SFD in kilonewton. Okay. This is simple way to draw SFD. Okay, according to values of SFD. Here I will repeat once again. Here, shear force at the point A on left side value will be 0. If you see at the point A on datum line, left side 0. Then this force is upward which means it will goes in upward direction because the value of shear force at the point A on right side 9.6 kilonewton, that is positive on the right side. In the portion AC, there will be no load. If the no load is given, how to draw shear force? Draw the horizontal straight line. Horizontal straight line up to the point C. Then here at the point C, the force is downward and the value of C on right side minus 10.4 kilonewton. Negative values are plotted below the baseline, whereas positive values are plotted above the baseline. And according to that rule, the value at the right side of the point C is negative minus 10.4 kilonewton. Then here again in the portion CB, there will be no load, and that's why I draw the horizontal straight line. Then here it will go in upward direction because at the point B, the load will be in upward direction. This is a simple way to draw SFD in kilonewton. Then draw BMD. How to draw BMD? First, here, first draw the datum line. This is datum line. Then BM and A and BM B will be 0. Then no load means inclined straight line. Okay. Then bending moment at the left side, that value at the left side 28.8 kilonewton meter. Then according to couple moment 8 kilonewton into meter. That is anti-clockwise. Anti-clockwise means it drop, it goes downward. The right side is 20.8 kilonewton into meter. You remember one thing, if the direction of the moment is anti-clockwise, then if you want to draw BMD, then always drop line. Okay? And if the moment is clockwise, then if you want to draw BMD, then that line will goes upward direction or it will goes in a rise. Okay? Anti-clockwise means drop and clockwise means rise. Okay? Here at the point C on right side, the value is 20.8 and left side 28.8. In between a moment, if you see here, that is anti-clockwise 8 kilonewton into meter. Anti-clockwise, which means that line will be dropped, and if the force, if the moment is clockwise, what will happen? It will rise. Okay. Then it will drop. Then the value at the right side 20.8. Then in the portion CB again no load. No load means draw the inclined straight line. Draw the inclined straight line. Draw the inclined straight line. This is simple way. I will repeat once again. Here, if you see here, bending moment at the point A and bending moment at the point B will be 0. Okay. Then first we write that 0 on the data line on left side, right side of the point A and B. Then here in the portion AC, no load is given, and if the no load is given, if you want to draw PMD, then draw incline straight line. Incline straight line. Then here at the point C, point load is given 20 kilonewton. There will be no effect. There will be no effect in PMD. There will be no effect. But at the point C, moment 8 kilonewton into meter, that moment is given. The direction of that moment is anti-clockwise. In that case, the bending moment already calculated at the point C on the right side and left side. Then if you see that value on left side 28.8, then you write that value at the point C on left side. Then moment is anti-clockwise, and if the moment is anti-clockwise, then that line will be drawn. Okay, if this moment is clockwise, what will happen? The line will goes in upward direction. The line will rise. Clear? Then on the right side, the value 20.8 kilonewton into meter. In the portion again say the no load. No load means draw the incline straight line. Okay. This is a simple way to draw BMD in kilonewton into meter. This is the SFD in kilonewton, this is the BMD in kilonewton into meter, and we can easily draw SFD and BMD according to values of SF and BMD. Okay, this is simple problem. Only one thing you remember: if the couple, this moment like this couple, okay, sometimes in problem couple is given. Okay, couple means direction of the force, means moment is given either clockwise direction or anti-clockwise direction. Because the couple it has a two type: clockwise couple, anti-clockwise couple. Either direction of couple is in a clockwise or either in anti-clockwise. Either clockwise or anti-clockwise. Here the direction of this couple is given anti-clockwise. In some problem, the direction of couple is in clockwise also. Okay, doesn't matter. But we remember, if the couple is given, and if you want to draw BMD, and in the BM calculation, then we take that point. It has two sides, either left or right side of that point, because at that point couple is formed. Okay, and if the couple is formed at any point, and if you want to draw BMD, then that point is considered left side and right side of that. Okay, you can calculate bending moment on left side as well as on right side of that point. Okay, and if you want to draw BMD at particular point where couple is formed, then if you see here, the direction of the couple is in anti-clockwise, then the line will draw in drop, the line will draw in downward direction. If you want, if the couple is clockwise, the line will be drawn in upward direction. Okay, that is the difference. Means if that direction of the couple is in anti-clockwise, then that line will be drawn. If the direction of couple is clockwise, at that point the line will rise. Okay, if you want to draw BMD at that particular point, this is the simple way to draw SFD and BMD. Okay, Um, I will take also another different type of example which is related to couple. Most of the time, any type of beam is given and couple is formed at that particular point on the beam. Then most students face some difficulties how to calculate BM and how to draw BMD at that particular point. You can, if the beam is given and point load is given, you can easily calculate RA, RB, you can easily calculate SF, BM, you can easily draw SFD, BMD. But the couple is given and UDL is provided. And in that case, student face lot of difficulty for calculation of SF and drawing BMD. Then I will take other problem like